So, Gray Dwarf Stars. This is a really cool paper. I wrote this a few years ago. For those people who are new to this theory, I want it to be elaborated on. That this isn't just something that appeared yesterday or a year ago or 3 years ago. I've been working on it for over 8 years now. As well, there are others that have a few years under their belts as well. Taylor, he's been working on it for some time now. Daniel Archer's been helping me out. Gosh, there's a lot of people. I can't even do everybody justice because they all have their own level of helping me out. But anyways, for those new viewers, this paper was in August 2nd, 2013. Over 6 years ago, Gray Dwarf Stars. According to the establishment, all objects can be classified by mass. If the object is really heavy, it is a star. If it is small, like Earth, then it is a planet. This 18th century justification is ad hoc, as they do not realize that star evolution is planet formation itself. And I wanted to share this really old paper with you guys. I say really old, it's only 6 years old. Because it has one of the original diagrams that I had cooked up. Hopefully it focuses. Focus. I don't know. I'll link this to the bottom so you guys can see it. But you see this black area? This was the area that I had to work with. Now, naturally, that gray wasn't there either. So just look at this black area and kind of do like one of these numbers. Let's see here. Almost like that. And you'll notice how it stops at kind of like the dark red, right about there. And I'll link this bottom so you guys can zoom in on it. But naturally, any person who recognizes patterns, any kid, child, young man, young woman, will take one look at this graph, the black area, and say, well, look, it looks like it's going down. You know, look. It looks like it just starts up here, really high, and then it just looks like it goes down. Just like that. And that's exactly what it does. That's exactly what stars do. They lose mass, they lose energy, they lose their size, they lose their radiance, they lose their giant gravitational fields, their magnetic field shrink. Baz is working on a new video on that. Keep going on it, Baz. I know it's going to be very difficult, but to be honest with you, it's a learning experience for me too. And gray dwarf stars would sit between browns and blue dwarfs, which would be Neptune and Uranus. I know Daniel Archer had made another list. I have to remind myself to look at it, but basically this is where I was going in the very beginning. I was like, wait a second, this graph just keeps on going like that. And the grays sit right about here. And that's about the stage when the star you can't see it anymore. It's almost invisible. The brown dwarf stars have strong infrared spectrums, but then once the brown dwarf continues losing mass and continues losing energy and shrinking, it becomes a gray dwarf. So, and I picked gray because I was a bit between brown and blue, and for sure they probably are really gray, which is kind of cool. Can you imagine if one day we look at the telescope data that we get in from the James Webb, and we can actually figure out what color the star is by its spectroscopic composition when it passes in front of its host. We'll be able to measure the atmosphere and then make models for what the atmosphere actually looks like, what the color is. But anyways, that graph continues and continues and continues. And these are all the stars that no longer shine. Naturally, they don't even have the classical Harvard spectrum classification. And as you'll notice here, this is the magnitude. Absolute magnitude is -5 on the top, 0, 5, 10, 15. And the numbers go up, but that means the magnitude goes down. And that means these objects down here, their magnitude is so weak that You know, just like the Kepler and test space telescopes, they need them to pass in front of a host star in order to see them, because they'll see a dip in the light curve. And that's exactly what's happening. All these very old stars, these very, very old stars down here, are passing in front of the young hot stars. And the problem with astronomy is that they're classifying the really old stars as planets and exoplanets. And these are stars they're classifying as being mutually exclusive. They're taking this bottom part right here and sticking it up here. And that's not true. This is an evolutionary line. And to show you how much further it went, how much further this has advanced, this is the updated Wolynski-Taylor diagram. And the majority of the sun's or young stars' heat and light lasts for a couple 100 million years, but then it reaches a point to where it starts aging considerably into the billions of years and eventually trillions of years, and it breaks up into little pieces. This is one hell of a graph. Mickey Callahan sent me a message stating that somebody had a problem with how I formed granite, and they said that the Wolynski-Taylor process, no, it's the Wolynski-Taylor diagram. Stellar metamorphosis is the theory. There is no process of the Wolynski-Taylor process. That's not true. It's a diagram. It's a diagram of stars as they evolve from hotter, brighter states into much more evolved states. And the Wolynski-Taylor diagram has what's called phase curves, which are these radial curves, and transformation curves, which is like that little red line right there. And a transformation curve is the line that the whole star evolves on. The phase curve is just a similar line at a different time. So, you know, I went over that in another talk. And gray dwarfs on this sit between Jupiter and Neptune. Gray dwarfs are basically between 550 and a billion years old, 1.2 billion years old for the most part. But I mean, they can be younger or older. See that little dot right there? So that basically wraps that talk up. I wanted to share this with you to think about, you know, the exoplanets and how many there are. As you'll notice here, I basically didn't have the counts good, because this makes it look like the counts of these are going to match the counts of these, when in reality there are very, very, very few of these in comparison as you move down the graph and the objects get more and more numerous, and there are more of them because they've had more time to age. And that's what this graph shows, that the whole thing expands considerably. And notice this is an exponential growth in years. So it isn't a million years, 2 million years, 3 million years, 4 million years, 5 million years. It's a million, and then 150 million, and then a billion, and then 65 billion. And also keep that in mind that the this graph has 65 billion on it. Okay? Anybody can see where that would conflict with what the dogma says is true. The dogma says the entire universe is 13.7 billion years old. Now, I don't know how many of them actually believe that, but I think it's absolutely ridiculous to say that they can determine the age of all of existence. Because what are you comparing it to? What are you comparing all of existence to? If you have something in addition to all of existence, it's still all of existence. That's what universe means. So to say universe has an age, I don't think these astronomers know how to communicate. But anyways, just throw that out there. These objects that we have in the galaxy are easily into the trillions and trillions of years old. And those are the objects that are rocky and have been just completely annihilated over many, many trillions of years of wandering the galaxy. Or even other galaxies, when galaxies collide together and they mix material like giant blenders. So that's a huge possibility too. We could have objects. The moon could be an object from another galaxy altogether. So could Mercury. Two solar systems from two different galaxies would pass by each other and boom, exchange material and pass off an object that's been around for longer than the galaxy itself. I'm sure that's happened many times. We see pictures of colliding galaxies in astronomy textbooks. Halton Arp had his catalog of peculiar galaxies. I suggest you look that up. And more than peculiar galaxies, we are dealing with a peculiar mentality. Now that we have a new version of stellar evolution of planet formation, essentially they're the same, and the astronomers, they're still off in La La Land doing whatever it is they're doing, completely ignorant of the changing facts and the reinterpretation of the facts as well. All right, guys, it's a late night talk here. I thought I might as well just get these thoughts out so I don't brood over them all night tonight and won't get any sleep. All right, y'all, later.